Hello and welcome back to Properties of Parallelograms. Today we're going to talk about parallelograms, some different properties they have, and how you can solve different sides and angles given a parallelogram. Okay, so we're going to start off with 5 different rules. The first rule is that a property of parallelogram, opposite sides are parallel. Again, opposite sides are parallel. Remember, parallel means that that the lines or the segments have the same slope and they're never going to touch. Okay, so opposite sides are parallel. Second thing, opposite sides are congruent. Congruent just means that they're the same, so opposite sides are parallel and the same. Property number 3, opposite angles are congruent. So now we have sides are congruent, opposite sides, and opposite angles are congruent. Property number 4, consecutive angles are supplementary. Consecutive angles are supplementary. Remember, consecutive is a fancy word for next to each other. When I talk about angles, a lot of the times I refer to angles that are next to each other as next door neighbors. Okay, there's 2 types of next door neighbors. Okay, so I'm going to put that over here, next door neighbors. Next door neighbors. Okay, if we have a line going this way, okay, you could think of this as a property line. Okay, one house is here, house number 1, and the fence kind of runs this way, weird fence, but house number 2 is on the other side. It's just next to it, other side of the fence. Okay, so house number 1, house number 2. Okay, we call these types of neighbors linear neighbors. This is a linear pair. Okay, the other kind of neighbors that we can have are neighbors that are across the street from each other. Okay, so here's a line just like that. Okay, this time you've got a street over here, and then you got a street over here, and these have to be parallel. Okay, so for parallel, I'm just going to put these little arrows. Okay, so these 2 streets are parallel. You've got house number 1 and house number 2. Okay, these are consecutive. They're consecutive. They're right next to each other. They have no fence in between them. Consecutive angles. Okay, so that's what we're talking about when we say that consecutive angles are supplementary. There we go, supplementary, not supplement, supplementary. Alright, last property of parallelograms, number 5, diagonals bisect each other. Diagonals bisect each other. Remember, bisect deals with angles, so for bisecting, if diagonals are bisecting, that means that the angle is split into 2 equal parts. Okay, so let's go ahead and take a look at a few examples. We're going to start off with number 1, just like we always do. Number 1 is going to be our first example. Let me zoom in on that for you there. Here we go. 1. See if we can focus this a little better. Oh, come on. Nope, that just got worse. There we go. Come on. Come on. Yeah, buddy. There we go. Perfect. Number 1. Okay, we're going to apply our 5 properties that we just talked about to number 1. The first thing that we need to do is find AD. Okay, so here's AD. I'm just going to outline it in black. Remember, properties of parallelograms. Opposite sides are congruent. Okay, how do we know it's a parallelogram? Well, in the directions, it tells us that each quadrilateral is a parallelogram. So the opposite sides are equal. Boom, boom. Opposite angles are equal. Boom, boom. And then these two guys, A and C. Okay, so AD is 8 because BC is 8. DC is 15 because AB is 15. Okay, those are the opposites. They're not touching. They're opposite of each other, and they're parallel. Opposite sides are parallel. Opposite sides are congruent. Angle A. Okay, this is a tricky one. How are we going to figure out angle A? The only angle that they gave us is D. Okay, remember, rule number 4, consecutive angles are supplementary. So angle A is consecutive. It is a consecutive angle with D. Okay, so angle A and angle D are consecutive. Angle A and D are consecutive. So that means that I can do 180 minus 68, and that's going to give me angle A. Okay, so angle A, when we do that, angle A is equal to 112 degrees. Boom. Okay, angle B. Angle B is opposite of the 68. That means angle B is 68. Angle C is opposite of A. We found A, it's 112. There we go. That's number 1, ladies and gentlemen. Number 1. Okay, let's take a look at number 3. Number 3 introduces diagonals. Remember, diagonals bisect each other. That's property number 5. Okay, let's go ahead and label this picture a little bit. So the 27 is across from UT, and then RU is across from ST. So there we go. Remember, opposite angles are equal, so U is opposite of S, and R is opposite of T. Alright, let's do this thing. 18 and ST go together, so ST is 18. UT, where's UT? Here it is. UT is opposite of the 27. Okay, VS. VS. Here's VS right here. VS. Okay, how do we know what VS is? Okay, VS, check this guy out right here. We got UV, which is 7. Okay, the 7, this is where diagonals bisect each other comes into play. Okay, 1, 2, 3, 1, 2, 3. Okay, so UV and VS are congruent, and then VT and RV are congruent. We may need some more information for that guy. We'll come back to that in just a second. Okay, so VS is 7 because UV is 7. Here's a piece of information that we haven't used yet. RT is equal to 30. Okay, so RT, this entire length right here, is 30. If we split 30 into 2 equal parts, 30 divided by 2, that gives us 15. So we end up with 15 for RV. And for VT, we get 15. So that's how we get our VT. VT is 15. That's number 3, ladies and gentlemen. Okay, let's check out number 5. Okay, when you see a big picture like this, Okay, the first thing that you're going to want to do is make sure that everything is labeled. Everything that they give you needs to be labeled on your picture. So XY, where's XY? Here it is. XY is 15. Okay, that makes WZ 15. WX is 22. Boom. That makes ZY 22. ZX is equal to 52. So 52 is this entire length. We need to split that into half to get each one of these. Okay, so when we split 52 in half, we get 26 and 26. WT is 23. 1, 2, 3, 4. That's 23. That makes TY 23. Alright, moving on to the angles. WZY. WZY. That's the large angle we're talking about here. So the large angle is 72 degrees. Boom, just like that. WXT. WXT. Okay, this guy right here is not the full thing, it's just half. Okay, so that is 35. WXT 35. And lastly, we have ZWT equals 59. ZWT. Start at Z, go to W, then go to T. So this one right here is 59. Boom. Alright, let's go ahead and start filling in the sides. ZW. We already put that down. It's 15. ZY. 22. TX. So we go T to X. We already took care of that number. Remember, that was half of our 52. That's 26. Just divide 56 by 2. Next up, WY. WY is asking for this whole length. Okay, so we have W to T. That length is 23. From T to Y, it is 23 as well. So if I go all the way from W to Y, I'm going to add the two 23s together and get 46. Okay, so WY equals WT plus TY. WY equals 23 plus 23, and that is 46. Okay, this is just segment addition postulate. That's all that is. Alright, next up, we're going to take a look at some of these angles. With the angles, it's always best to make sure that you know which angle you're working with. So this first one, we start at T, go to Z, go to Y. So TZY. Here's TZY. Okay, that is this bad boy right here. Okay, right where the black dot is. Okay, so TZY. How are we going to figure this bad boy out? Remember, okay, because of our properties of parallelograms that we did up at the top, that opposite sides are parallel. So, if I look here at WZ and XY, those two lines are parallel to each other, and ZX is a transversal line. So, TZY, this guy right here, is alternate interior angles with this 35 degrees. TZY and angle TXW are alternate interior angles. Okay, remember, alternate interior angles are congruent. So this guy is 35 degrees. XYZ. Start at X, go to Y, go to Z. So we're talking about this large angle here. Okay, this guy's a little tricky. what we're going to do is we are going to skip it for now and come back to it in just a second. Next up, XWT. XWT. Okay, we're going to skip that one too. I promise we will come back. We will. XYT. XYT. Okay, time to talk about these guys. They're all three pretty tricky. Okay, remember, parallelograms, all parallelograms, anything that has four sides, so parallelograms equal the total sum of the interior angles. Parallelograms. That is totally not spelled right. Let's try again. Parallelogram. Parallelogram. There we go. Parallelograms have an interior angle sum of 360 degrees. Parallelograms have an interior angle sum of 360 degrees. Okay, so we know already that these two are 72. So let's go ahead and add those. 72 plus 72 plus this big guy. So we'll just call him X. Since these two are the same, we'll just say two X's. So X plus X equals 360. 72 and 72. That makes 144. So you have 144 plus 2x equals 360. Take this guy away. Got to do it on both sides. We get 2x equals, this makes a 6. 216. Okay, so 2x is equal to 216. Divide both sides by 2. And one angle, this one of these large angles, is equal to 100 and 8 degrees. 108 degrees. So let's come back here. Okay, this large angle, XWZ. We have XWZ? No, we don't. We have XYZ though. Okay, so let's do that one. XYZ is equal to 108 degrees. Good. XWT. Okay, here's XWT. This guy right here. Okay, we know that this angle has to be 108 degrees. We already got a 59. Let's do 108 minus 59. See what that gives us. We already know that's going to be a 9. 0. Here's a 10. This becomes the 9. 18. There we go. Boom! 49. XWT is 49 degrees. Right there. Last one, XYT. XYT. So this guy right here. Okay, to find this one, again, we're going to come back here to the parallel lines that we have. Okay, so there's 1, here's 2. Now this time the transversal's right here. So the 59 and this big dot are alternate interior angles. Okay, so that means that they're both 59 degrees. Bam! Oh man, I've been leaving you guys off the screen there. I really apologize for that. I'm sorry. Okay, that right there, ladies and gentlemen, is number 5. Go ahead and flip it over. Looking at the back side now. Okay, number 7, you're just going to set the sides equal to each other. I'm not going to do that one. We'll skip over it. Number 9 is pretty similar. Make sure that you label the picture first. Number 11, remember, opposite angles are equal to each other, so you set these two equations equal to each other. And number 13 is somewhat of a doozy. Okay, this one has multiple steps. Let's go ahead and knock this one out real quick. Number 13, this is our last example that we will do together. Okay, so we got 4x plus 9 right here in black. Okay, here's my set of parallel lines. One here, one here. Since 4x plus 9 is on this line, that's going to be my transversal. So I got one here. Here's my other angle right here. So this guy is 4x plus 9. Okay, so that's labeling the picture. Let's come up here. If measure of KLH, where's KLH? KLH is 134 degrees, so this big guy is 134. Solve for x. Okay, same principle applies here. Remember, parallelograms equal 360. So I have two 134s. Okay, these two guys are 134. So 134 plus 134 plus, check it out, we have two of these, because this 25 can come over here. So what I'm going to do is do 25 plus 4x plus 9 plus 25 plus 4x plus 9 equals 360. Now you can see, man, this sucker got real long. I don't like that. So what I'm going to do is I'm going to rewrite it in a different way. Okay, since I have two 134s, I'm going to do 2 times 134 plus 2. I have 225 plus 4x plus 9s. Okay, these equal 360. This kind of condenses things, makes it a little neater. Now all we do is we use the distributive property. So the 2 goes to everything inside the parentheses. We use the distributive property to help us simplify this. 2 times 134 is equal to 268 plus 2 times 25, which is 50, plus 2 times 4x, that makes 8x. 2 times 9 is 18. And that is equal to 360. Combine all your numbers together. Okay, so we got 268 plus 50 plus 18. 268 plus 50 plus 18. That's equal to 336. Plus, don't forget about your 8x. Plus 8x equals 360. I'm going to subtract the 336 from both sides. That one cancels out. 8x is equal to 24. Divide both sides by 8. We get x equals 3. There's our answer, ladies and gentlemen. That's problem number 13.